Hello students, how are you? Hope you all are fine at your homes. Students, today I am going to explain the topic that is three-dimensional geometry, which is chapter number 11. Students, in last week we have discussed about the equation of line in three dimensions, or direction ratios and direction cosines of a line. Today, now we will discuss the equation of planes, means we will discuss or derive the three equation of planes. First is, if the normal of the plane and its distance from the origin is given, means suppose we have given a plane in three dimension, we will find the equation of that plane if its normal to the plane and the distance from the origin is given. And second equation, it passes through a point and perpendicular to a given direction, means we will derive an equation of a plane in three dimension if it is passing through a given point and perpendicular to a given direction. And third one is, it passes through three given non-collinear points. We will derive the equation of plane in three dimensions if the plane is passing through three given non-collinear points. Students, first we will study the equation of the plane in normal form. We will study the equation of plane in normal form. So students, here we have a figure. In figure, suppose we have three dimensions, x, y and z, and we have a plane in three dimensions. Suppose we have a point P, that is x, y, z are the coordinates of that point, and position vector is r vector, and d is the perpendicular distance of the plane. Clear? D is the perpendicular distance of the plane and n is the normal vector or normal form of the vector. So students, now see, if ON is the normal form of the origin to the plane, means ON is the normal form, the origin to the plane, then an n cap is the unit normal vector. Here we have n cap, means n cap is the unit normal vector. Then ON is equal to d n cap. Clear? ON is equal to d n cap. If NP is perpendicular to ON, so we know NP is perpendicular to ON, means this is perpendicular. Then we have NP dot ON is equal to 0 because we have dot product. In case of dot product, if there is angle of 90 degree, that is the product of two vectors is equal to 0. Clear students? We have studied in the previous chapter in vectors. Okay, and NP is equal to r vector minus dn vector, means NP is equal to r vector minus dn vector. Why? Triangular law of the vector addition. We are applying the triangular law of the vector addition. So here we will put the value of that NP in this equation. Suppose this is equation number 1. We are putting the values NP in equation number 1. We have r vector minus dn vector dot product dn vector is equal to 0. That is equal to r dot product n vector is equal to d, means n unit vector. Remember students, n is unit vector. So students, listen carefully. If there is n unit vector, then this is a perpendicular distance. Clear? If it is not unit vector, then it will not perpendicular distance. It will just a scalar quantity. If there is, suppose if the equation is in the form r vector n vector equal to d, clear, then this d will not the perpendicular distance. If here we have n cap, then this d will be the perpendicular distance. Clear? Now come to the Cartesian form of this equation. Here OP is equal to r, OP is equal to r is equal to xi plus yj plus gk cap, and n vector n cap is equal to li plus mj plus nk. So students, on multiplying these two, taking dot product of these two, xi plus yj plus gk is equal to li plus mj plus nk is equal to d by putting in this value in this equation. So here we have Lx plus My plus Ng is equal to d. That is the Cartesian form of this equation. So students, here Lmn are the direction cosines we have studied in the previous video. But suppose the equation is in the form r vector into n vector is equal to d. Then this is not a perpendicular distance. Then this equation will become ax plus ny plus by plus cg is equal to d. In that case, ABC will be direction ratios. Clear? That is the difference between Lmn and ABC. Lmn are the direction cosines and ABC are the direction ratios. Now we will study equation of plane perpendicular to a given vector and passing through a given point. Means we will study equation of plane which is perpendicular to a given vector and passing through a given point. So here we have a figure. Here we have three dimensions x, y and z. Suppose this is a plane which is in three dimensions. This is origin and this is point P. X, y, z are the coordinates of that point and position vector is r vector. Now we are considering the plane is passing through a given point. Suppose that point is A. The plane is passing through point A and A vector is the position vector of that vector, and plane is perpendicular to a given vector and that perpendicular is n vector. Means this perpendicular is toward upward of the plane. So we will find out the equation of that plane. Let r be the position vector of any point P, x, y, z and P lie in the plane. If and only if P will lie plane, if and only if AP means AP is perpendicular to n. Means if AP is perpendicular to n, then there will be position vector P, x, y, z. Clear? Then there P will lie. Clear? Then AP dot n vector is equal to 0. That is again cross product of the AP and n vector. Sorry, dot product of AP and n vector, and angle is 90 degree. So AP dot product n vector is equal to 0. But AP is equal to r minus a vector. Why? Because we are applying again triangular law or factor addition. Here AP means AP vector is equal to r vector minus a vector by triangular law of vector addition. So by putting in this equation, in equation number 1, we have r minus a vector dot product n vector is equal to 0. This is the vector form of this equation. This is the vector form of if equation of line, plane, perpendicular a given vector and passing through a given point. Now students, we will come to the Cartesian form of this equation. Let A be x, y and z. Suppose the x1, y1 and z1. Suppose the coordinates of A are x1, y1 and z1, and P, the coordinates of P are x, y and z. The coordinates of these are x1, y1 and z1. Clear? And direction ratios of n are a, b, c. Means now n is the normal vector. Clear? Not it is a unit vector. So here the coordinates of this will be direction ratios. If n is the unit vector, then the coordinates of this n will be the direction cosines. So direction ratios of n are a, b and c. So a vector is equal to x1 i plus y1 j cap plus z1 k cap, and r vector is equal to x I cap plus y j cap plus z k cap, and n vector is equal to a I cap plus b j cap plus c ck cap. On putting all the values in this equation, we get a into x minus x1 plus v into y minus y1 and c into z minus z1 equal to 0. That is the Cartesian form of this equation, where a, b, c are the directional ratios of n and x1, y1 and z1 are the coordinates of point A and x, y and z are the coordinates of point P. Now come to equation of plane passing through three non-collinear points. Non-collinear points means when three points are not on the same line, then the points are called non-collinear points. We will find the equation of plane when that plane is passing through three non-collinear points. Suppose that points are R, S and T. The position vector of R is A vector and position vector of S is B vector and position vector of T is C vector. So this plane is passing through three points. Here we have P. The position of P is, position vector of P is R vector. The coordinates of P vector is X, Y and Z. So in previous equation we have seen R into A vector, R minus A vector n vector is equal to 0, where n was the perpendicular. Clear? So here see, the perpendicular will be R S vector cross RT vector, means R S vector cross RT vector. On cross product of RS vector and RT vector, we will get the perpendicular. Clear? Because in cross product we know, if we are taking a cross product of two vectors, then the resultant of that two vectors will be perpendicular to the both vectors. Clear? So here this will be the perpendicular, means this will be the perpendicular to RS vector and RT vector. So at the place of n we put RS vector cross RT vector. Clear? So R vector minus A vector dot product RS vector cross RT vector is equal to 0. Here R vector minus A vector is dot product V vector minus A vector cross product C vector minus A vector. See students, here RS vector is equal to V vector minus A vector, because the position vector of R is A and position vector of S is B. So in order to write RS vector, we have to write B minus A, means S minus R. So B minus A. In case of RT vector, the position vector of T is C and position vector of R is A. So we have to write C minus A. RT, so C minus A, means T minus R. C minus A. So on putting the values of RS vector and RT vector, we have this equation, and this equation is the vector form of the equation if plane is passing through three non-collinear points. Now come to the Cartesian equation. In Cartesian equation, we have determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. Clear? From that we will get a equation, that is the Cartesian equation of this plane, where x1 y1 z1 and x2 y2 z2 and x3 y3 z3 are the coordinates of these points R, S and T. So students, that's all for today. Hope you have understood. Take care. Bye bye.